Hello everyone. In this section, we are going to talk transportation problems. Actually, we had met this kind of problem when we talk about the dual simplex method. In example 3.9, and we talked how to shift TVs from two different locations to another two different locations, right? We use dual simplex method to solve this problem. And in this section, we are going to deal with more general transportation problems. We may have more sources to more destinations. So here, let's look at example 6.1. Here we have 3 sources and 4 markets. And here you can see there are different amount of supplies from different sources and different requests from different markets, right? And the cost are also different, right? And here we have one assumption, that is, we assume that the total supply equals the total demand. And here, please pay attention. Whenever we start to work on a transportation problem, we first want to check whether or not the total supply equals the total demand. For this example, we could check that the demand is you're adding all those amounts request from the markets. That's 360. And you check those what we have in these different sources. We have totally 360. You probably will ask, what if they're not the same? We will deal with it later. Okay, now in this question, we first assume that Xij denote the amount to be shipped from origin I to the destination J. So you could see that $10 is the cost from from the source 2 to market 3, right? We can denote this as the Cij as the cost, right? And now let's build up LP problem for this one. So this is the LP problem we built up for this example. And here we have 3 sources and 4 markets. You could see that we have 12 variables there for the LP problem. And it is a minimization problem, and we have 3 supply constraints and 4 demand constraints there. If we write it more clearly, use some notation, and you can see that we have 3 supply constraints because we have 3 sources, right? And we have 4 demand constraint for 4 markets. So in this way, when we write it in this some notation, we could see that if we have m sources and n destinations, then that make us to have what? M supply constraints and n demand constraints. That make that we just for I from 1 to 3 change to I from 1 to n, and j from 1 to 3 4 to 1 to n, right? So that give us more general look. Okay, so actually in this example, we can see those data are most important. So we actually may denote just collect all the data. So one is the cost matrix, that's capital C, that for each row you could see the entry on that C2 3, that is from second resource to the market 3, right? The cost is for 1 unit $10. And then we also have the data for supply, so we can put them together to form supply vector and then demand vector. Although they are different size vectors, but you add all the entries together, that's the total supply, and add all the entries for the demand vector, that's the total demand, right? So what we need is the total supply equals the total demand. In general, if we have the demand equals the supply, then actually the constraint, okay, each of the constraint, that is a equality, not greater than equal to or less than equal to, it is equal to. So here we can easily to prove it in general case. Just so we suppose we have m supply constraints, so we write them as a sum xij less than equal to si and I from 1 to m. So if we add all the constraints together, we should have the total sum of the xij less than equal to the sum of si, right? And the same, if we add all the demand constraints together, we have that the sum of xij greater than equal to the sum of dj. And if, because we know when we have the demand equals the supply, then that means sum si equals sum dj. And this actually leading to what? With these two inequalities, and we actually have that sum of xij equals sum of si and equals sum of dj. So in this way, all the constraints should be equalities. In this way, the general transportation problem, we can write it in this form, that is minimize the cost, that sum Cij multiplied by Xij, and then subject to the supply equations and the demand equations. But we have this, the supply equals demand, so we have an extra one. This one actually make that the total supply and demand constraints one less. Okay, just one of them should be redundant. Okay, so here the property of transportation problem should have following properties. One, a transportation problem always has a feasible solution. You can put whatever you like, just simply put it there if you don't care about the cost. So the problem always has a basic feasible solution. You always have those non-negative solutions there. Okay, and then the set of feasible solutions is bounded, because we have a bounded request there. And the third, that one of the m plus n constraints, one of the m plus n constraints into is redundant by that constraint 3. Okay, so in this way, we also can look at those variables, and you could find out each variable appears in exactly 2 constraints. And also the column vectors of the constraints, if you list them, you could find out the column vectors are linearly independent. Now, how may we find that the solutions for the transportation problem we are not going to use that 12 variables, use dual simplex method to solve it. Here we built up a new form of the tableau. Please see the left on the screen. In the example 6.1, you could see that I have a table that formed with 3 rows and 4 columns that I put each block with that the cost entry. See that C11 is 5 in the example. That is the cost from source 1 to market 1. So I put it as the first block. And then you could see that this square table, I put it that exactly we have what? 3 rows, 4 columns that corresponding to the 3 sources and 3 markets. Okay, and then we put the demanding vector, the demanding amount for each market, I put above the table, and then the supply vector, those put on the left side of the table. And this forms a tableau. And now we needed to fill that initial basic feasible solution into it. Okay, how may we put the basic feasible solution into this one? Here we first introduce minimum cost method. The minimum cost method was written in the red color. That is said, choosing an initial basic feasible solution using the minimum cost rule, that is for each row I equals 1, 2, 3 to until m, assign the maximum possible amount xij of the remaining supply to the cheapest route. Okay, what does this mean? If we back to the tableau, here you just we first start first row, and in the first row in each block you could see that the first one, 5, cost $5, $7, $9, $6. So 5 is the smallest cost, right? So here we put as many as possible amount into it. You see that in the market 1 we demand 100 units of the commodity. So from the source 1 we actually have 120 units, so we only need 100 for the market 1, and in this way 100 is the maximum amount we can ship from the source 1 to market 1. So we put 100 into the first block, and we just look at the first row. Here we still have 20 remain in the source 1, right? And then we check the remaining 3 blocks on the first row. That's 7, 9, 6. So 6 is the next cheapest cost. So we put the 20 into it, and the first row is done. That means the source 1 is done. But you could look at it. The market 4 will get 20 from source 1. So the market 4 need another 100 units, right? Okay, now we just go to the second row. To the second row, we could find out the 5 is the cheapest price. So here we are going to put as many as possible to the cheapest one. And as we just mentioned, that market 4 got 20 from source 1, so it only needs 100 there. So in this way, we put 100 into it, and that tells us, okay, the market 4 is done. We already don't need any more there. So the source 2 give 100 to the market 4, then it has another 40 left. Another 40 left, you look at the second row, there are 6, 7, 10 there. So 6 is the cheapest one. However, market 1 is already full, right? It already got 100 from source 1. So we cannot put any to market 1. So you can only have two choices. One is 7, one is 10. Of course, we choose the cheap one. That is cheaper one, that is 7, right? So we put the remain 40 from source 2 to the second row, second column, that one, that 7 in the 7 block. So that is 40 there. And you could see from the top under the table. And then you could see that from the source second row, we are done because the source 2 have 140 units and 40 go to market 2 and 100 go to market 4, right? And then when we look at the markets, only we need 20 in market 2 and we need 80 in market 3. And you could see that in the source 3 we have 100 units there, so we just put that 20 into the second block in the row 3 and then 80 in the row in the block, the third block in row 3. So in this way we fill that the first tableau that gives us how to distribute these commodities into different markets. So this one, if you read the right side, each block in the transportation tableau is called a cell, right? So the value of xij, just each cell we can use xij to represent. So this cell is recorded in the cell ij. So actually in the tableau 1, you could tell that the initial tableau tells us x11 equals 100, x14 equals 20, x22 equals 40, x24 equals 100, x32 equals 20, and x33 equals 80. So this tells us when we have the initial tableau, then we already have a basic feasible solution there. For the rest, x12, x13, x21, x23, x31, x34, all the others are non-basic variables. They have value 0, right? So here, let's go back to this, the right side of the state that we set up V1, V2, Vm be the set, and those be the dual variables corresponding to the supply constraints, and then let W1, W2, Wm be the dual variables corresponding to the demand constraints. Then we can easily to write the dual problem to the transportation problem as maximization problem. And note that those the original transportation problem, it was a minimization problem. All the constraints are equalities, right? Equalities. So that means all these dual variables are unrestricted. And for the constraints, because all the variables in the transportation problems are greater than equal to 0, that was a minimization problem greater than equal to 0. So the constraints in the dual problem of the transportation problem should be have constraints less than equal to. So that means Vi plus Wj less than equal to Cij. This is the dual of the transportation problem. And here, if we just make it more clearly, we just simply settle that the original transportation problem z value equals the sum of zij, xij. So whenever zij equals cij, that means xij is a basic variable. Otherwise, xij are non-basic variables. So when we have zij equals cij, that xij is a basic variable. So we know the corresponding constraint in the dual problem should be Vi plus Wj less than equal to Cij. We add a slack variable Tij into the constraint. You look at the green corner on the left in the middle. And we add a slack variable Tij into these constraints. Then if xij is a basic variable in the transportation problem, then we know by the complementary slack list, we know that the corresponding dual slack variable Tij should be 0, right? So in this way, it turns to whenever xij is a basic variable, we have the constraint in the dual variable satisfied Vi plus Wj equals Cij. Okay, whenever xij is a basic variable, and we have Vi plus Wj equals Cij in the dual problem. Okay. Then, once we build up initial tableau, we can easy to calculate the cost that equals what? 5 C11 multiplied X11 plus C12. For the others, because they are non-basic variables, they have 0 value, so we don't count it. So here we have that 5 multiplied X11 100 and 6 multiply that 20. That's what the cost. That's the cost for the from source 1 to market 4, right? So that's a 6. C14 equals 6. 6 multiplied 20. And we adding all this together, we get the total cost is 2,160. That's the cost. Now, how may we make it work to find optimal solution, to find the cheapest cost? So we first need to find entering variable, right? An entering variable for the tableau. And how to find the entering variable? If we read the right side of the screen, you can see that first of all, we solve the dual constraint equations corresponding to the basic variables for the remaining m plus n minus 1 dual variables. The value of one dual variable will have to be chosen arbitrarily. What does it mean? If you look at the tableau T1, you could see we have 6 basic variables, x1, x11, x14, and the rest, right? 6 of them. And how many dual variables do we have? We have V1, V2, V3, W1, W2, W3, W4, right? So we have 7 dual variables. And for each basic variable xij, we have an equation Vi plus Wj equals Cij. We know the value of Cij, right? So in this way, we will have 6 equations about that 7 dual variables, just vi plus wj equals cij. And we want to use these 6 equations to solve those dual variables. Then 7 dual variables with 6 equations, basic variables, 6 equations. That means we have to set one of the dual variable as an arbitrary value, right? Free variable, right? So here, normally, okay, basically we, for a tableau, whenever we have transportation problem, we normally have m plus n minus 1 basic variables that gives us m plus n minus 1 equations. That's vi plus wj equals cij. And we want to get the value. We want to get m plus n. We want to get a value of the m plus n dual variables vi and wj. Okay, now what we do is normally we set one of the unknowns 0. Normally we set the one that appears most in those equations vi plus wj equals cij. We set up one of those unknowns vi or wj 0, and then we can solve the rest of them. Okay, and once we have the value for the dual variables, and then we look at those non-basic variables. For those non-basic variables, we evaluate this equation zij minus cij, that we settle it equals to vi plus wj minus cij. Because we already find all the values of the dual variables, then we can simply calculate those values, right? So once we calculate all the values, we go to the step 3, step C. The step C said that the entering variable is xij, where zij minus cij is the largest positive value from step B. So here, that means when we calculate all the zij minus cij for those non-basic variables, we just compare them. We choose the one who has the largest positive value, then corresponding basic variable, non-basic corresponding the non-basic variable will be the entering variable. Okay, and if all the zij minus cij for those non-basic variables are non-positive, then we stop. We already find the optimal solution. Okay, now let's look at the left side. Here we have m equals 3, n equals 4. So in this way, we have 3 plus 4 minus 1, that equals 6 basic variables, right? Okay, we have 7 dual variables, v1, v2, v3, w1, w2, w3, w4, right? And then 6 basic variables. You could see that those basic variables are x11, x14, x22, x24, x32, x33, right? So for each of them, we just, you can first subscript represent for vi, and the second subscript of the x, that means wj, right? So here we x for x11, we have v1 plus w1 equals c11. We know c11 equals 5, so that leading to an equation v1 plus w1 equals 5. So x for x14, we have v1 plus w4 equals 6, and x22, v2 plus w2 equals 7, and for x24, v2 plus w4 equals 5. Then we have the rest. Now, which one we should set up as 0? As what we told that is set one of the unknowns the one that appears most. But in this example, you could see in these equations, the 6 equations, V1, V2, V3, and W2, W4 all appears twice, and W1, W3 appears once. So you can choose any of that V1, V2, V3, W2, W4 to be 0, and choose one of them to be 0 and then solve for others. But here, normally I choose set V1 equals 0. So when I set V1 equals 0, the first equation gives that W1 equals 5. Second equation gives W4 equals 6. So when we know W4 equals 6, then you go to the fourth equation, V2 plus W4 equals 5. W4 equals 6, C24 equals 5. So that leading to V2 equals minus 1. When we have V2 equals minus 1, then the third equation gives that W2 equals 8. And when we have W2 equals 8, the fifth equation gives V3 equals minus 2. When we know V3 equals minus 2, the last equation tells us that W3 equals 10. So in this way, we solved all the dual variables. V1 equals 0, V2 equals minus 1, V3 equals minus 2, W1 equals 5, W2 equals 8, W3 equals 10, W4 equals 6. So once we work out all the dual variables, we are going to calculate Zij minus Cij for those non-basic variables. Check the tableau. We found that for X cell 1, cell 1, cell 1, 2, cell 1, 3, those represent variables x1, 2, x1, 3, right, respectively. And they do not have value. That means they are zeros, right? So non-basic variables. So for these non-basic variables, for example, x12, we just simply work out z12 minus c12, that equals to what? v1 plus w2 minus c12, that equals 0 plus 8 minus 7 equals 1. And we work on all of them, that we found that Z4, Z34, no, for Z34 minus C34 has the most largest value, positive value 3. So in this way, we choose that x34 to be the anti-invariable. Okay, so here x34 is the anti-invariable. So this one, x34 is here. This one to be anti-invariable. Okay, and then how may we choose the departing variable? It goes to here. How may we choose departing variable? First, determine which basic variable xpq will decrease when xij is increased. Just the one we choose anti. We will form a loop. The record of this change forms a loop, a sequence of cells in transportation tableau that satisfy 3 conditions. One is the sequence consists of alternating horizontal and vertical segments. Second, each segment joins exactly 2 cells. 3. The first cell of the sequence is the last, and no other cell is used twice. Okay, keep this in your mind. Now let's look at the example. On the most left, you could see I have closed curve rectangle connect with that x cell 22, cell 24, and X, and cell 34, and cell 32. How may I choose it? It is like that. If you look at x34 to be entering variable, then you just suppose we shift 1 unit in that cell, and that actually means we need to reduce 1 from the what in the market 4. You just look at the column. Okay, look the column market 4, that if we want to add 1 into from source 3 to market 4, then we may reduce 1 unit from source 2 to market 4, or from source 1 to market 4. If you look at that we reduce 1 from source 2 to market 4, so that you could see in the cell that 2, 4, I write a -1. So in the cell 3, 4, I add 1. In the cell, I reduce 1. This actually means that we market 4 will get 20 from source 1, 99 from source 2, and 1 from source 3, right? Okay, now if we reduce 1 from source 2 to market 4, the source 2 has 1 more, right? So another place need to increase 1 so that we can dispute 140 from source 2 to be others, to be finished, right? So in this way, when we decrease 1 from cell 24, then we can increase 1 in cell 22. And when we increase cell 22 with 1 unit, that means in that column, because market 2 only need 60, right? So if we increase 1 from source 2 to market 2, then we have to reduce 1 from what? Source 3 to market 2, right? So basically, whenever you have the entering variable, you just work on it. You have to keep the balance for each column and each row so that it will work. Okay, so in this way, just when we work on that, so that cell 3, 4 increase 1, then cell 2, 4 has to reduce 1. When cell 2, 4 reduce 1, then cell 2, 2 has to increase 1. And then cell 3, 2 has to reduce 1, right? So all these, when we build tableau loops, it has to choose from those basic variables. Okay, for the rest of them, the non-basic variables, they are zeros, so you don't want to deal with it. Okay, now you probably say, what if I increase 1 from source 4 to market 4, source 3 to market 4, and I decrease 1 from source 1 to market 4. And you could see in the cell 1, 4, if you reduce 1, that means you have to increase 1 in what? In that cell 1, 1. Cell 1, 1 is already full with 100 because market 1 needs 100 there, right? So you cannot give more to it, more than 100 to it, right? So in this way, you can't go any further. Okay, you can also choose it from the row doesn't matter which way you go. You see that what we did was along market 4, right? We increased one in the cell 3 4, and then we needed to reduce one from what cell 2 4 or cell 1 4. Or you can first choose along that sources. If from the source 3, I increase one, I want to put one into the cell 3 4. I may reduce one from that 3 2 or 3 3 because those two are basic variables. You could see if you choose decreasing one from that 3 3, the 80, you could see that in this column there's no other basic variables. So if you reduce one, you couldn't increase to others. Okay, so in this way we actually set up the loop is from what cell 3 in 3 4, cell 2 4, and cell 2 2, and cell 2 3 2, right? Cell 3 2. So here we make the loop like I start with x3 4. x3 4 goes to x3 2 and goes to x3 x2 2 and goes to x2 4 and back to x3 4. And here we know x3 4 is the entering variable and x2 x32 is the departing variable. How do we decide x2 to be the departing variable? Actually, according to what we wrote on the right side, is that you choose that the one, if entering variable increase, that one decrease, right? So here you could see that if we increase one in cells 3 4, and we need to reduce one from cell 2 4, and then increase one in the cell 2 2, and decrease one from cell 3 2. And what you need to do to choose the departing variable, you just consider those with -1 there. Those cells you need to reduce unit, right? So you could see at most you could reduce 20 in the cell 3 2, and in the cell 2 4 you can reduce 100. So if you want to make the loop working, keep the balance, you can at most reduce the 20, right? So in this way, x32 is the departing variable. Okay, what summarize it? If you choose the departing variable, you just collect those cells with -1 there, and then just reduce units and compare them the smallest amount. The cell with the smallest amount should be for the departing variable. Okay, so in this way x32 is the departing variable. When we set up a departing variable, build up the loop, we want to know if we choose it correctly, when we make this change, if we can save some money. So we just simply add those costs just whenever we shift 1 unit. Okay, how much we can save. So you could see that if we increase 1 in the cell 2 2, we need to have we need to pay $7. If we reduce 1 from 2 4, that means we save $5. If we increase 1 in cell 3 4, that means we need to pay $1 and reduce 1 from 32, that means we save $6. So that's 7 minus 5 plus 1 minus 6 equals minus 3. So whenever it's negative sign, that means if we do this change, we will save $3. Okay, we save this amount whenever it is. So we want to, in this way, we want to minimize the cost. That means we want to do the shift as many as possible. So here we have total at most 20 to be shift to cell 3 to 4, right? So in this way, we just change all of this. So we can form a new tableau, set the departing variable to be 0, set the entering variable equals to previous value of the departing variable. So that means x34 will be 20 and x32 should be 0. That becomes non-basic variable. And we have to adjust x22 add 20 and x24 reduce to 20. So in this way we built up a new tableau. As you notice that when we calculate to find the basic variables, when we have those back to here, when we have this amount initial tableau, when we want to calculate the entering variable, there's a lot of calculation. We needed to solve 6 equations with settle one dual variable equals 0, and then we need to calculate the non-basic variable with zij minus cij, right? A lot to write down. Actually, you could see that when we built up a new tableau, it's quite clear. Not so many calculations there, right? So this one, please pay attention here, okay? Before I do it, I just want to calculate, see if the total cost is smaller than the last one. You could see that the C, what I got, is $2,100. So actually, we saved $60 from this change, right? Okay, now, because in last tableau, when we try to find out the entering variable, we used those equations to find values of the dual variables and then work on that zij minus cij for those non-basic variables. And when we have a new tableau, we have to repeat the process to find until we reach optimal solutions, right? So here, to calculate those equations, find the value of dual variables, we don't want to write all of them down because we know for each basic variable xij, we know vij, for each basic variable xij, what vi plus wj equals cij, right? So here we know we list all the basic dual variables v1, v2, v3 for that supplier dual variables, and the w1, w2, w3 as the dual variables. We just write them in that right side of the tableau or bottom of the tableau. And you could see that for basic variable x11, that c11 equals 5. And then we have the equation that v1 plus w1, that the most right above that v1 plus the bottom in the column w1 should equals to c11, right? And the same as the rest, you could see that for example that x24 is the basic variable. So C24 is 5. So V2 plus W4 equals 5, right? And we have those equations you could see from those dual variables. Just from top row you can see it. Now, first we choose 1, 0. Now let's see how to solve it. Okay, you're going to see that for basic variable appears in the top row on the fourth column, right? You could see that x1, 4, x2, 4, x3, 4. Those are basic variables. That means in that equation, vi plus wj equals cij. W4 appears the most. So we simply settle W4 equals 0. And when W4 equals 0, you could see that, okay, V1 plus W4 equals C14. So that means V1 plus 0 equals 6. That means C1 equals 6. So actually from here you can easily to get C2 equals 5, C3 equals, V2 equals 5, V3 equals 1. Because V3 plus W3 equals C3, 4. That's 1, right? And V2 plus W4 equals C2, 4. That's 5, right? So you could easy to work out it in this just from the table, very easy to get it. And then when you have V1 equals 6, you could see that V1 plus W1 equals C115, right? So that V1 equals 6, then W1 equals minus 1, right? So in this way, we can very easy to get that values of the dual variables. Okay, once we get them, then you don't have to calculate that Zij equals Cij, because we use Zij, we use that Vi plus Wj for those non-basic variables. So in this way, you just find out, okay, that x12 is a non-basic variable. So Zij equals Z12 equals V1 plus W2. You simply add V1 equals 6, W2 equals 2. Adding them together is 8. You just put 8 there. And then you just use C, that what? Zij minus that Cij. So 8 minus 7 is 1, right? So you don't have to do it immediately. You just add that Vi plus Wj for each non-basic variable. For example, and x13 is a non-basic variable. So V1 plus W3 equals what? 6 plus 7 equals 13. I put 13 there. You could see that on the first row, the third cell. You can see we have a 13 there. That's V1 plus W3. And C13 is 9. So we just simply use V1 plus W3 minus C13. We get it 4, right? So the difference, you can easy to see it. Okay, now for each that second row, first column, that is C21. C21, V2 plus W1 equals 4. And for the cell C23, that is V2 plus W3, that's 12. And then V3 plus W1 equals 0 in the cell C31. And then V3 plus W2 equals 2, that's 3. So in this way, once you write that small letters in those cells, just simply use them to minus the Cij and find which one has the most value, largest positive value. So 8 minus 7 equals 1, 13 minus 9 equals 4, 12 minus 10 is 2, 4 minus 6 is negative, 0 minus 7 negative, and 3 minus 6 negative. So actually you reach what? The not just the positive value, is V1 plus W3 minus C13. That's what in the cell 13. So in this way, x13 is the entering variable. And when x13 is the entering variable, you plus 1 there. And then you could go down. Okay, you just, okay, I increase 1 here, and then I decrease 1 from the other basic variable along the column. That is x what? x33, right? So that minus 3 there. And then when that x3 minus 1, that means x34 increase 1, x3 increase 1, and we back to x14 decrease 1. So in this way we build up a loop. So here I have to mention that, can we just from the cell 34 to the cell 32, and then from cell 34 to cell 24, and then go to cell 14. That's not allowed. You understand that whenever we build up the loop, okay, the sequence consists of alternating horizontal and vertical line segments. You cannot choose 3 of basic variables in a column or in a row to make the loop. So you only choose 2 cells connect vertically and then go to horizontally. So when you choose that cell 34 to cell 24, then you have to turn it horizontally. So it has to be turned to what? Cell 22. You can't go up to cell 14. Okay, so in this way we set up the loop. Okay, and you probably say, what if I want it to go to and from cell 34 to cell 24, and then you turn to cell 22. When you increase 1 in the cell, you want engine 1 to it, you go to 8 in that cell to 4, and if we go to the cell to 2, you could see that along the second column there's no other basic variables. You can do the loop, you can connect with it. So in this way we have the loop is from x11 to x14, and from x14 to x34, and from x34 to x33, and then back to x13. And here you can look at it from the row change, that the first subscript of the variables are the same, 13 to 14, and then we from 13 to 34, 14 to 34, that the second subscript are the same. You can see that. And then from 34 to 33, that is what? That is the first subscript of the variables are the same. And the same you could work on that x13, x33, the second subscript are the same. Okay, so in this way we make up the loop. Once we make up the loop, that you could see which one should be the one departing. Compare cell 14 and the cell 33, and you could see that the 20 less than 80. So in this way, that's the most amount we can shift, right? Reduced from cell 14. So in this way, x14 is the departing variable. So x13 is the entering variable, x14 is departing variable. Right? Now, if we work on how much we can save if we shift 1 unit, okay, just that when we have one more in that cell 13, that means it costs us $9, and then reduce 1 minus $6 plus 1 plus $1 and minus 8 plus minus $8. So actually this one we have it save what $4 if we make this change, and then we can form a new tableau now because we already find entering variable, find the departing variable, then we put the amount of the departing variable to the entering variable, then adjust the amounts in the rest cells on the loop, right? So here we have the second, then the third tableau. When we have the third tableau, if we calculate the cost, it is 2020. So we saved $80 already. And now, if we look at this one, here you can see that V1 appears twice, and V2 appears twice, V3 appears twice, and this two twice. So whenever it's like this, I normally set V1 equals 0. When V1 equals 0, I can easily to get that W1 equals 5, W3 equals 9. And then when I have this from W3 equals 9, I can get V3 equals minus 1. When I have V3 equals minus 1, we can get that W4 equals 2, because 2 minus 1 plus 2 equals 1. That's the C34, right? So when we have W4 equals 2, then we get V2 equals 3. When V2 equals 3, we get W2 equals 4. So we finish the values of all the dual variables. Then we just simply add that V1 plus W2 for non-basic variable x1, 2, and non-basic variable x14 with V1 plus W4 equals 2. And move W for non-basic variable x21, that's V2 plus W1 equals 8, and V2 plus W3 equals 12. Okay, here 12, just write it here. Here is 12. Okay, 12 here. Okay, put 12 here. And then we work out the rest of them. You could see that 4 minus 7 negative, 2 minus 6 negative, 8 minus 6. Okay, that's positive. Also 12 minus 10 positive. The others are negative. So here you could see 8 minus 6 is 2. 12 minus 10 is also 2. You may choose either of them to be entering variable, but here I choose the first one, so that x21 to be entering variable. Okay, you can try to choose that x23 to be entering variable. Okay, you could work on that. Here I just simply choose that x21 entering. When I choose x2 entering, that means I increase 1 here, then that x11 has to reduce 1. x11 reduce 1, then we have x13 increase 1. When x13 increase 1, then x33 reduce 1. x33 reduce 1, that means x34 increase 1, x34 increase 1, that means x24 increase 1, and then from x24 we can back to x21, right? So this loop is a little bit complicated, although we have a cross section at the cell 2, 3, but there's no changes there. I just cross it, right? Okay, just look at it, that when we draw the loop is vertically, horizontally segments alternated. Okay, so we can make this loop. All right, already write it there. So in this way, you could see that which cell we have reduced units, that is cell x1 C11, C24, and C33, and compare those amounts in these cells. So 60 is the smallest one. So in this way, x33 departing. And now, if we make this change, how much we can save? Here, I think I had one notate, write it wrong. This one should be 5. Should be 5. Yeah. Okay. So here, you just check that. Here we increase one here. That's increase one in cell 2-1, and this costs $6, and but we decrease in cell 1-1, so that reduce 5, and then plus 9, and then what, minus 5, and then plus 1, and then minus 8. So when we add all this together, it is negative 18 and plus negative 16 equals minus 2. So in this way, if we make this shift, and we will save $2. Now, form the new tableau. And this one gives us the new tableau, and the cost actually is 1,009 hundredths. So this actually, when we make the last shift, we saved about $120. So this one, when we work on it, you could see that V2 appears the most. So we set V2 equals 0, that gives us W1 equals 6, W2 equals 7, and W4 equals 5. And with this, we can easily to decide that V1 equals minus 1, V3 equals minus 4. So when we calculate that Vi plus Wj for those non-basic variables, you could find out those that Vi plus Wj minus Cij for all the non-basic variables are less than or equal to 0. So at this stage, we reach our optimal solution, that is cost z equals 1,900 at x11 equals 40, x13 equals 80, x21 equals 60, x22 equals 60, x24 equals 20, and x34 equals 100. The rest of other xij equals 0.